Greetings. Today's topic is about a mathematical phrase or concept of algebraic expression, which is a mathematical phrase or a number sentence that has at least one variable and an operation which is an addition, a minus, a multiplication, or a division, and it does not have any equal signs. Algebraic expressions are important because they are the fundamental building blocks of algebra and higher mathematics. And they are important because they are used to create formulas, solve real life problems, simplify problems, and to generalize patterns. As we explain further, the algebraic expression is made up of terms which are part of an expression that are separated by an operation. The operation, as we mentioned, can be an addition, a subtraction sign, a multiplication sign, and a division sign. Now we're moving forward into breaking down the expression and mentioning the key components that make up the expression. Firstly, we start with the coefficient, which is a numerical factor of a term that contains a variable. A variable can be explained as a symbol or a letter used to represent a number that we do not know yet, meaning the unknown. The letters can be A, B, X, Y, and Z, which are the commonly used letters of the alphabet. Last part of the expression is a constant. A constant is a number that is by itself with no variable. An algebraic expression does not have an equal sign. If it does, then it becomes an equation. Now we're taking the misconceptions of teaching algebraic expressions. Teaching algebraic expressions is fundamental. However, the misconceptions can hinder a student's understanding for years to come. The misconception can arise from how concepts are initially presented and the language used. The first misconception is that the letter, which is the variable, represents a thing and not a number. This can hinder a learner's understanding for years to come. Now, how to address it? We can address this by stating that by using the precise language, always say that the letter represents a number or the unknown. Another misconception is that teachers often use the words or the language that simplifying means getting a single number. That is not always the case, because simplifying does not mean that. The expression 2x plus 3 cannot be simplified to a single number. And this happens because students carry this goal into algebra, as arithmetic mathematics is focused on finding a numerical answer. Now, how to address this is to reframe the goal. Explain that in algebra the goal is to simplify an expression, not necessarily into a single number. The most common misconception is that the coefficient and the variable are two separate things, which is not always the case. As this happens because the multiplication sign is omitted, making the operation invisible. To address this is to reintroduce the operation, explaining that 2x is 2 multiplied by x, as it cannot be shown on the expression. Language is very important. Now we are going to address the misconception made by Mr. Thomas on the given scenario. 2x plus 3 is just an expression. Now, if we were to solve it, we will have to isolate the variable. As you can see, the terms given, another one has a variable, another one does not, which makes 3 a constant number and 2 a coefficient. To address the misconception, firstly, we simplify. As you can see, it is already simplified. Then we evaluate, then we solve. As we're going to go down with that formation, we're going to introduce 0. So it will be 2x plus 3 equals to 0. Now the aim is to solve for x. We will have to isolate the variable. So we're going to minus 3 on both sides since we introduced the 0, which makes plus 3, a positive 3 and negative 3 cancel each other. Hence we have 2x equals to negative 3. Now we are solving for x, isolating the variable. Then 2x will be divided by 2. Then on the other side, minus 3 will be divided by 2. What you do on the left hand side, you do on the right hand side. Then the answer will be x equals to negative 3 over 2.